So we have discussed about bitwise and operator, or operator, and right shift operator, right? So there is one more operator called left shift. That is 10 left shift 1. So right shift is nothing but shifting the bits. See, shifting the bits means, for example, if you take a number 10, so what is the binary number of a 10? This is a binary number. You can take a 34 in your behavior, right? So 34 is this one, right? So this is 34. So if you do like this, 34 right shift 1, that means right side I want to remove one bit. This one I want to remove. If I remove right side, say these are the bits. This is left side, this is right side. So right shift means I want to move the bits right side. So these are the bits, right? If I move them, if I push here, so this bit will move aside. That means it will go like this. Okay. That means now earlier there was 0 here. To move the bit, that means this 0 will be gone. Now how many bits you are moving, that many bits you have to add here, like zeros. That many zeros you have to add here. For example, let's say there is a binary number like this. Take an example like this. There is a 10 10 10 101. Now what you are trying to do? You are trying to do left shift 3. So left shift 3 means, right shift 3 means right side 3 bits you have to move. That means this one, another one, this one. So this 3 bits you have to remove from here. So remove right side. And how many bits you are removing, that many bits you have to add here. That many zeros you have to add. 1, 2, 3. So this is called right shift. Left shift means same time. You will move the bits this side. So now you will move right side, right? So this is right shift. Right shift means right side, that many bits you have to remove. How many bits you are removing? The same number of zeros you have to add left side. Now if you take the another one, that is left shift. This is completely opposite to that one. So left shift means left side you will remove the bits and right side you will add the zeros. That is a left shift and right shift. So what will happen? For example, let's take one number. If you take any number, for example, if you see here 42, right? So the binary number of 42 is this one. So this is the binary number of 42. Okay. So if I do right shift of 2, that means I want to move 2 bits. If I move 2 bits, what will happen? This 1 0 will be gone. And left side I will add 2 zeros, 0 0. Now what will happen? If you convert this number to binary number, this is a binary number. If you convert this number to normal number, then that number will be changed, right? So if you check it, so if you copy this, if you convert to integer, so what will happen? int of comma 2 10. What happened? From the number 42, if you do left shift, where it is? 1 second. So if you do right shift, if you are removing 2 bits and adding 2 zeros, then the value will become as 10. So you are shifting the bits. That means you are changing. So ones and zeros you are changing. So how you are changing? 2 times. 2 bits you have to change. You have to remove 2 here and you have to add 2 zeros here. In the same way, if you are giving left shift, so left side 2 bits you have to remove and you have to add 2. Okay? You have to move, you have to remove the bits. So right shift means right side you have to remove the bits. So how much number you are giving here, that many numbers we have to remove. That's it. So left shift means left side, that many numbers we have to remove. So after removing, so the opposite side you have to add. So right side means right side I will remove 2 bits. The opposite means left side I will add 2 zeros. Left shift means left side I will remove 3 bits. Opposite means right side I will add 3 zeros. So after removing and adding, whatever the binary number is there, if you convert that number to the normal number, whatever the value is getting, that will be the final value. So overall, the bitwise operator, it might be AND operator, it might be OR operator, it might be left shift or right shift. So all these are what? You are playing over the bits. On each bit, you are trying to do a manipulation, bit level manipulation you are trying to do. So that is a bitwise operator. I have no questions in this bitwise operators. That means we are done with this operators part. So arithmetic operator, logical operator, comparison operator, membership operator, bitwise operator. So these are the different operators that are available in Python. Anybody has any questions in this operators? Let me know. Anybody has any questions?
Clear, sir.
Okay. So if we are done with this concept, then the next concept will be flow control. Flow control statements. So flow control, the name itself we can understand. The flow control. So we are controlling the flow. So which flow? The program's flow. However the program is trying to flow, however the program is trying to move, that movement you are catching and you're taking the control in your hands and you can play however you want. Under this flow control, we have three different things. The first one is decision making. Or we call as a conditions, that is if conditions. Second one is loops. Third one is functions. So these are the three things that falls under the flow control. So let us discuss what exactly this flow control deals. What is this flow controls? Why this concept is added in this particular program? What will happen if you are not using this one? So till now we are writing a program, but we are not using any flow control. Then why we need this one? So what is the purpose of this particular concept in this particular programming? So we'll discuss all those things. Okay. So now B and print 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 B. Let's say this is a program. So program means what? Writing instructions. So these are my instructions. I am trying to give, I want to talk to the system, that I want to inform the system that do these things. I have mentioned all them line by line. Now I want to inform the system to do this. However, I have mentioned the system will start doing that. So how to inform now the system? Python space. So this is one. So if I run this particular program, so see 10, what happened? 10, 45, 55, minus 35, 10, 45, 55, minus 35. So the system has performed the instructions. Now observe here one thing carefully. The point that we have to observe here is from which line the program got started. At which line?
A equal to 10.
Program starts with A equal to 10. Okay, someone is saying program starts with line number 4, someone is saying line number 5, someone is saying A equal to 10. So I want a gunshot answer. From which line onwards the program will start? I informed you these things. Did we discuss about this one? How does a program will execute? When we are talking about the interpreter, when we are talking about the compiler, what we have discussed? Hello? Guys, am I audible to you?
Yes, sir.
Yeah, so I'm expecting an answer from you. So if you're not answering, then I cannot move ahead. From which line onward does the program starts working? If you are not able to understand this particular part, I'm not able to understand how you have this, how you have understood all the concept till now.
It started with print A, sir.
So the program starts with print A from this line onwards. If program is starting from here onwards, now you are saying print A. Now what is A?
A means 10.
10. How does the program know that A is 10? Now the program is starting from line number 4, right? Bro, program line number 4 నుంచి స్టార్ట్ అయితే ప్రింట్ ఏ అంటున్నావు. ఏ అంటే ఏంటి? దానికి ఎలా తెలుస్తుంది లైన్ నెంబర్ 4 లో?
A equal 10. A is a variable.
Where you have filled this a variable? Where is this 10 is storing inside this A, and which line that is you are defining? Where you are creating this variable A?
Second line.
Second line. If you are creating the variable at second line, if the program is starting from fourth line, then how does the program knows about this A? You are creating at line number 2, but program is starting from line number 4. That means line number 2, line number 3 are skipped. Directly the program is starting from line number 4.
Yes, bro. The print compiler starts with 4.
What did I ask you? Did I ask you about the print compiler? Execute line by line. It will first execute this line. Next, it will execute this line. Next, it will execute this line. Next, it will execute this line. So the program starts from line number 1, starting line, this one. From here to here, everything will be executed step by step. Yes or no?
Yes,
Then
sir.
I don't know why you are saying line number 4 and line number 5. So the program execution will happen from top to bottom. From first line to last line, the execution will happen. Whatever the first thing that you have written, it will pick up that thing. Then it will go to next line, then 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 next line. Now, if you observe here, what happened? First, 10 is printed because at line number 4 you have written print. Then this one, then this one, this one. So last, what is the print is there? D. That is A minus B. You're trying to print D. So after printing this D, what will happen? Now initially, the program will start from line number 2. It will execute this line. Then it will go to 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 this line. Then go to this line. Then go to this line. This line. This line. So after completing line number 13, what will happen? After completing line number 13, what will happen?
The program will end.
The program will end because after that nothing is there. So this is the last, right? So now if you observe here, from line number 2 to line number 13, everything happened one by one, right? Everything happened one by one, and it happens only one time. After completing line number 13, is it again it is going up and printing all the things? No, right? It started from line number 2. It done line by line everything. It reached last line. After reaching the last line, the program got ended. So it's a one-time job. So everything will be done from starting to ending one time. Now, After completing fourth line, will the program again go up like this? Again come down? Is that is happening here? Line number 4, 5 print అయిన తర్వాత మళ్ళీ పైకి వెళ్ళి మళ్ళీ కిందికి వస్తున్న program.
No, sir.
No, right? So that is not happening. So if the program is starting from line number 2, it will start from here. It will go step by step down. After reaching like one by one step down, it will never again come up. Again, it will never come up and again repeat those things. So every line it will go step by step and it will do only one time. So this is the general flow. This is how the program will execute normally. Not only this one, right? Whatever you take a list, you take 1, 2, 3, 4, 5 something. You do a dot append. You add something. Okay. Let's say you have done a dot append append something. After that you are printing a. You are printing a. Then you done a dot append append some 99. Then again you did print print a. Now what happened when you run this particular program? The program will start doing from line number 2 because this is the starting line. So it will create this a. Then after creating is done, then go to the next step, append. Then go to next step, print this one. Then go to next step, again append, then print. Now after printing this one, will it go to again line number 5 and again add one more time? No, right? That will not happen. Or let's say after completing all these lines, again it will go to line number 2 and it will create one more time a. After creating 2, it will come to line number 6. So these things are not happening. The jumping, going back, so all those things will not happen because generally the flow, I am talking about the flow. Flow means how the program will start executing. The program will start executing from line number 2. It's not about line number 2. From the beginning line, top to bottom, whatever the top line is there, from that line to step by step till last line. Once it reaches the last line, then the program will stop doing. That means everything it will do only one time. That means if this line is completed, it will go to next line. If it is reaching the next line, it will never go up again because that is done. This job is done. Now it is going to next line. So next job has to be do. After doing second line or third line, it will never go up again. It will come in downwards only because the flow is top to bottom. So this is generally how the program will execute. Now, the purpose of this flow control, the flow control means what? Whatever the flow is there, whatever we have discussed till now, that is the flow. If you want to control that flow, if you want to change that flow, if you want to change everything and take into your control, take into your control means first do this line. After doing this line, directly go to 6th line. After going to 6th line, again come to line number 3. After coming to line number 3, now go to line number 5. Now this line number 5, do the same thing 10 times. Repeat the line 10 times. So you can do like this. So we are changing everything. So whatever the flow is there, that flow we are taking into our hands. We are taking the control of that flow and we are trying to change everything. So that is the concept of flow control. You got the point? So how we take the control, how we change, how we skip the lines, how we go to from one line to another line, that we will discuss in this particular 3 concepts. But now I wanted to explain you why this flow control, what is the purpose of this flow control. So did you got the point now what exactly the flow control means? Hello?
Yes, bro.
Guys, did you understand? So now, in this, the first one is decision making. So decision making means you are checking So let's say let me take one example. Guys, are you able to see my screen? Sorry?
Yes, sir.
Yeah.
Yeah.
Why it is not enabled here to show?
Look, half an hour.
Okay. So now, guys, assume that this is one highway. Okay. So you're traveling from your home to Bangalore, or it can be any from one point to another point you're traveling. It can be a vehicle that you can consider it by bike or etc., whatever the vehicle. Now, this is your traveling. So now, when you're traveling from your hometown to Bangalore, what will be happen is, like, in the meanwhile, in the roads, there will be some checkposts, right? So what is the purpose of checkpost generally?
To checking the documents of bike or
Correct.
license. I think.
Correct. So in the checkpost, what the police will do is they will stop the vehicle, they will check the document. Okay, they will check the document. They will ask whatever the documents they want. If everything is okay, then only they will allow the vehicle to pass on the checkpost. If the documents are not valid, then what they will do? They will not allow the vehicles to pass from this checkpost. They have to go back. Yes or no? So, on this road, if the police is not allowing, then what you will do? You have to take another road, because this is a highway, shortcut way. This is a newly built highway. Let's say newly built highway. If the police is not allowing, then what you will do? You have to take the. What you have to do? You have to take in this particular way, right? You have to come like this. Yes or no? If they are not allowing, this is a check post. You will take another road. You will come like this and you will join this road here. You're getting the point what I'm trying to explain you.
Yes, sir.
Let's say you're traveling from your hometown to Bangalore. There will be one checkpost. What the checkpost will do? They will check the documents. If everything is okay, then only they will allow you to come down. Move ahead, go forward. If not, you have to take another route. You have to come like this. So finally, you have to go to Bangalore. So if they are not allowing this way, you will come another way. But this will be a long. You have to come like this to just pass this tunnel. So now, similarly, the same example, what happens is, for example, let's take this example. You have A equals to 1, B equals to 2, C equals to 3, or you can take anything. Now what happens? When you run the program, the interpreter will start from here. First, it will do this thing. Next, it will do this thing. Now, however, you have checkpost here, right? The purpose of checkpost what? Checking. We have to check. Okay, we have to check. So now the program is going like this. From first line to last line, it is going like this. But if you want to stop, if you want to check, and based upon that, if you want to make a decision, then that kind of a checking. If in Python, if you want to create one checkpost, if you want to have one checkpost, that can be done with the help of a keyword called if. So what is if? If is nothing but a keyword. It is a keyword. So the meaning of keyword means the purpose of this if is already defined in the Python. So this is one of the keyword. Okay. So why we are using this if you want to check like this, if you want to, here the checkpost is, for what purpose they build a checkpost? They want to check the documents. So similarly, now we are creating one checkpost. Why do you want to create a checkpost? We want to check one thing. We have to check something. That's why I am writing an if. Why I am writing here if? I want to check. So in Python, if you want to check anything, whenever if you want to check anything, it can be anything. If you want to do some checking, if you want to do some checking, then that can be happen with the help of if. So now I am writing a if. That means I am trying to check here. So what you want to check? I want to write here. So I want to check this one. A greater than B. I am checking this one. If A is greater than B, colon. So remember this. Enter. So guys, lot of things has to be encountered now here. We have to focus very carefully. If I'm checking, what I'm checking? A greater than B. So come to this point. You're traveling like this. A equal to B, done. Sorry, A equal to 1, done. B equal to 2, done. Now you're coming down. While traveling, there is a condition, checkpost. If your license, your vehicle number, everything is proper, then you can go inside. Let's say this is one tunnel. Okay, let's assume that this is one tunnel. Okay, this is a big tunnel like this. Assume that this is one big tunnel. So if you want to cross this tunnel, there is a checkpost. If the police is giving you the permission to go inside, then only you can go inside. If they are not allowing, you have to take another road and you have to join here. This is the condition. Now, if they are allowing you, you can go inside, right? Listen carefully. Everything is, why I'm repeating the same thing is, if you understand this concept, then you will easily, you can understand that the Python concept. So if you are traveling if there is a checkpost and there is a tunnel, if the police is giving you the permission, you can pass easily to the tunnel. You can go inside. You can go inside the tunnel. If there is no permission, you have to come outside the tunnel like this. If you have permission, you can go inside. Now, the same way, if I'm checking, what I'm checking, if A is greater than B, then go inside. So we are saying go inside. How we are saying go inside? With the help of colon. So colon means you have to go inside. The inside region. There will be another inside region. So how that inside region we are categorizing? So after giving this colon, in the next line, we have to give one tab like this. See, listen carefully, observe carefully here. So when I write if A greater than B, after writing the condition, you have to mention the colon. So why we are mentioning the colon? The colon means it will tell that if this condition is okay, then you have to go inside. So you have to go inside will be informed by the colon. So what is the inside? Here we have to create the inside. So how you are creating? After the colon, in the next line, when you hit the enter button, it will come to here. Here we have to use one tab like this. So what I am trying to do is print, print A. This one. That's it. This is a program. Now, here I am writing print. Observe carefully. Print. Done. So listen carefully, guys. This is the most important concept. If you are not able to understand, then you will never learn the programming. So the actual logical thinking will start from here. See, what I am trying to do is, I am trying to travel from here to here. This is my starting point. This is my ending point. Now what happened is, initially I have created A equal to 1, B equal to 2. Now in the next line, there is a if condition. Everybody listen here. If, that means I am trying to check. What I am trying to check? A greater than B. So it will check this one. If this is okay, then what we have to do? We have to go inside. So how you are saying inside? If you observe here, line number 6, we have written inside. If you see line number 5, line number 3, line number 2, and line number 8, from the beginning of the line, we have start writing. But line number 6, we have started writing in the inside part. So this is called indentation. So indentation. Indentation. So indentation means the block. We call as one separate area, one separate block. So block means what? This is one area. So when this area has to be executed, see now everything we are informing to the system. What we are informing to the system? A system, take A equal to 1, take B equal to 2. Now check if A greater than B. Now check this thing. If this is true, then only go inside. So then only go inside. I am saying that inside. So how the system will understand it is inside? So there should be some difference, right? Inside and outside. That's why we are using this indentation. Now if you see, this line is starting from the beginning. This line is not starting in the beginning. Now the system will understand this is the inside part. Now this line is depending upon line number 5. So how can you say that line number 6 is depending upon line number 5? Because this line is written inside. And when this line will get executed, if line number 5, here if you are getting full permission, if everything is okay, if it is true, then only go inside. Like this. If the documents are correct, then only go inside the tunnel. You pass through the tunnel. If the documents are not correct, you have to go outside. So the same way. If this is true, if everything is okay here, then only go inside. If not okay, come to line number 8. Don't go inside. Directly come to line number 8. This is how it will happen. So this is called if conditions. So I'm checking one condition. If this condition is true, then do this. If this condition is not true, then do this. So depend upon this condition, either that or this. But how you are mentioning that or this? Indentation. If this is true, then only go inside and do this thing. Okay, so this will be done. And one more thing. Okay, first we will go base level. So if this is true, go inside and do this thing. If this is not true, then don't go inside. If you want to pass inside the tunnel, everything should be okay, right? Everything should be okay. All the documents should be verified. But in Python, when we can say is everything is okay, how the Python will check whether this is okay or not, whether you have a permission to go inside or not, how we will get a conclusion means it will do this one. So what is A now? A is nothing but 1. What is B? B is nothing but 2. So 1 greater than 2. This is true or false? 1 greater than 2. This is true or false?
False.
False. So if false, F-A-L-S-E, false. So if false means what? You don't have permission. If you are getting answer as true, that means you have a permission. So this is how the interpreter will get conclusion. In this example, we are checking the documents. If every document is okay, you can go inside. In the same way, here, if the answer you are getting is true, then only you can go inside. If the answer is not getting true, then you don't have permission to go inside. So again, I'm repeating inside. I'm repeating it again multiple times. Inside. So inside means what? See, this is inner region. This is outer region. All this line, if you see, line number 2 started from the beginning. This also started from the beginning. Also started from the beginning. This also started from the beginning. So all these are in same line. But if you see this line number 6, so we have used some space here. We have to use one tab space. So why we are using one tab space? Because we have to inform the system. This line and this line not are same. If you see, this print is different, this print is different. Both are not same. If both are in same line, then both are same region, same area. But now this is different region. This is different area. So different area. How you are creating that different area? With the help of the space. And this space in Python we called as indentation. This is nothing but separation. We have to categorize like this is different, this part is different, this part is different. So that categorization, that separation will happen with the help of indentation. Okay? Is it clear to you guys? Anybody has any questions in this?
No, sir, it's clear.
Observe it clearly. Take your time. Let me know if it is clear or not. Because in tomorrow's session, if I ask you a question, if you are not giving any answer, then that will be not a good way. So take your time. Let me know if it is clearly understood to you or not. The actual programming will be started from this particular point itself. So what is this colon? What are the spaces? Why this print is written here? Why this print is written here? You have that questions. You have those answers for those questions. Now, if I run this particular program, if you see here, what will happen? I am getting only done. If you remember that till now, till to this particular program, earlier, what we have discussed, wherever you are writing print, that will be displayed on the screen, right? Till now, in the previous sessions, what we have discussed, wherever you are writing the prints, nothing but those prints will be displayed on the screen. This is what we have discussed, right? But if you observe here, line number 6, this is also one print, but this print is not displaying on the screen because the interpreter is not reaching that line. To reach this line, this condition has to be satisfied. If this is true, then only it will go to this line. Then it will execute this one. After executing, then it will again come back to this one. But now, this interpreter has no permission to go inside. It has to come directly from line number 5 to line number 8. If you see, earlier, when you are not using if conditions, step by step everything is working. But now if you see, directly from line number 5 to line number 8, we are jumping. We are skipping this line. We are jumping, right? So we are controlling the flow. Usually the flow is step by step. But with the help of if condition, I am stopping that flow. I am checking something. If this is okay, then do this. If this is not okay, then go back. So this is the base part. We are making the decision. So we are informing the system. We are instructing the system. Hey system, you have to think. If this is okay, then do this. If this is not okay, then do that. If condition is used everywhere in a daily, so whatever things you are doing in your daily life, right? Everywhere the if condition will be used. The best example, your smartphone lock. You're typing the smartphone password. If the password is matches, then only open the lock. If condition will be opened. If condition will be used there. ATM pin, if condition will be used there. Everywhere, wherever there is a password based, that means if condition will be used there. Not only password, everything it can be, lot of things. So if conditions are that much importance. So it's not like an importance. Without this, there is no program. Okay, is it clear to you? Anybody has any questions?
Yes, bro. Clear.
Yeah. So now see, guys, this print, I am repeating it again. Try to understand it clearly and focus it. Line number 6. Here there is a print. Now this print will not directly printed. Now this line number 6 is completely depending upon line number 5. If line number 5 gives the permission, if line number 5 says that here the answer is getting true, then only it will go to line number 6. If here you are getting false, then what will happen? It will directly come to line number 8. Now if you observe line number 8, this line number 8 is a free. He is not depending upon anybody. Now whether this is true or false, this will be executed. This line number A is not depending on anybody, right? Line number 6, if you see, this is written inside. That means someone is taking care of this one. This guy is taking care of this one. He is the leader. He has the control. If he says okay, then only it will go inside. This will print it. But if you see this line, it's not like that. It's a normal line. Nobody will take the control of this one. It's a normal. Whether here it is getting true, whether here it is getting false, it doesn't matter. After completing of this task, it has to do line number 8. So line number 8 is a free statement. It's not about the if condition. Is it clear to you?
Yes.
Okay.
Yes, sir.
Now, what you are saying to your system, you are saying your system that a system take A equal to 1. Now take B equal to 2. Now then after that, what you are saying, you are asking your system to check who is bigger. So how you are saying to think your system, you are saying that hey system, first check. How the check will happen? With the help of if. If A greater than B, then do this. But you are not informing what if A is not bigger, what to do. See, observe the program here. You said that take A equal to 1, take B equal to 2. Now check A greater than B. If this is okay, that means if A is really bigger, then do this. But you have not informed what to be done in case of A is not bigger. Yes or no? You got the point? Now you said that if A is bigger, then only do this one. But if A is not bigger, then what to do? You got the point? అర్థమవుతుందా అర్థం కావట్లేదా?
Yes, sir, got it.
Yeah. So here we have only intimated if A is bigger, then do this one. So this is called simple if. That means there is only one if condition. If this is true, then only this will happen. But now we have one more, that is else. If else, else, E-L-S-E, else. Else, P-R-I-N-T, print P. Now listen carefully. Now what is this? Earlier we don't have this part. We have only if part. That means this is called simple if. But now we have else. This is called if else. If else is nothing but you are saying both the things. Two things you are saying. A system, check A greater than B. If this is true, then do this. Else, what is the meaning of else? If that is not true, then come to me. You have to do this thing. So you are saying both the things. When the password is okay, log into Facebook. When the password is not okay, you have to show some message right on the screen that the password is not correct. So both the things has to be handled. If the case means if it is true, what to do? If it is false, what to do? So you have mentioned both here. If A greater than B, if this is true, then do this one. Else, when this will come, if this is not true, then only it will come here, it will go inside, it will do this one. So else means what? If the above condition fails, then come to me and do this. If above condition passes, then do this one. That means either this one or this one. Any one print will be executed, but not both. This one or this one. రెండిట్లో ఒకటి మాత్రమే ఎగ్జిక్యూట్ అవుతుంది. Either this one or that one. In among these two prints, only one print will be executed, and that also depending upon the condition. If this is true, then print this one. If this is false, then go to else. Print this one. But now what about this one? This is not depending upon anybody. This is a free bird. Nobody can control this one. Now see, this print is depending upon the else part. This print is depending upon the if part. Now when the else part will come, if here the condition fails, if you are getting false, then this will be coming to the picture. When it will comes here, it will directly go inside because there is no condition. If here fails means directly come here, do this one. If it is pass means do inside, do this one. So this print is depending upon this one. This print is depending upon this one. So this is called if else. Clear? So you are saying, see,
Yes, sir.
everything what? Program means what? We are instructing the system. We are informing system how to think. Yes or no? Now, why to write this one? If you don't write like this, A is 1, B is 2, you don't know which is the bigger element. Who is bigger? Who is bigger? Sorry? Now A is 1, B is 2. Who is bigger? A is bigger or B is bigger? Then why you are writing these things? Directly you can say B is bigger, right? Why you have to write like this? What is the purpose of writing like this?
We are going to ask the system, sir.
You are going to?
We are going to ask the system.
So you are asking the system here, or are you informing the system here to do like this?
We are informing the system.
Then, but you know, right? Already A is bigger, B is bigger. Then why you need to inform the system? Now in this case, it is open. A equal to 1, B equal to 1 like this. Let's say I am taking, right? We have discussed about input, right? What is the purpose of input? Forgot.
Sir, no, sir. We can give the values while the program is running. At the time of
Input
running.
means See, no need to remember that level, bro. Input means what? Taking the inputs. That's it. You are taking the inputs. So let's say if I run the program, it will ask me to enter the value for A, right? Let's say I'm giving here some value X. I'm not opening. See, I'm giving value Y. Because at the time of running, I can give anything. Now, how does the system will understand? How does the system has to categorize? Now, we are human beings. We know one is bigger, two is bigger, one is smaller. But how does the machine knows that one? So you have to make the system to take a decision. That's why we are informing the system how to take that decision. So first we are saying that, hey system, check A greater than B. If A is bigger than B, then obviously A will be the bigger. Let's say this condition fails. Fails means who is bigger? If A is not bigger than B, then who will be bigger? Huh? If A is not bigger, then who will be bigger?
B.
Yeah. You're checking A and B. A is not bigger, then obviously B will be bigger, right? If two persons are there, one person failed the match, then who will be the winner? The next person will be the winner, right? So that's why I'm checking here. If he win the match, he is the winner. Else, obviously, the second person is the winner. Okay. So this is how the if conditions will be used. So else is not always to be returned. You can skip else. This is not a mandatory. You can remove this part. You can write simple like this one. So if you are not using else, then we call it as a only if. That means simple if. If you are using else, then we call it as a if with else. So the thing is that simple. If you are not using else means you are not informing what is the other case. If it is not true, then what to do you are not mentioning. If you are using else, that means you are informing both. If it is true, what to do. If it is false, what to do. So both you are informing. So else is a optional. You can mention, you can skip. The only thing is if you are mentioning means you are informing what to do in case of failure scenario. In case of positive scenario, what to do, you are mentioning both. So this is the example of if and else part. Let me know if you have any questions in this. Anybody has any questions?
No, sir.
No questions. Okay. So try to do these things. Now you have A and B. You are finding the biggest of these two, right? Let's say there are three A, B, C. Now there are A, B, C. Now you need to find the biggest of these three. How to find the biggest of these three? So try this. We'll discuss the next tomorrow.